Hi there, I want to show this module I have been given. So this module was sent to me by a C station, or by the people from the website, and they wanted me to make a review about it. So you may ask, what is this? It looks like an LED flasher. It looks like a LED flasher, but it is not. It's a so-called radar sensor. And what this does is it can be placed in a room, and if you enter the room it will turn on the light, and if you stay in the room and keep moving it will stay the light on or keep the light on, and if you leave the room after like 1 minute or so it will turn the light automatically off, which is very comfortable. So they wanted me to review this module, and if you have a look at the circuit board, I have looked at the solder joints. They are okay. They aren't the best ones that I've ever seen, but they are definitely okay, so the parts hold well and nothing is wrong. If you look here you see the S&D parts, but if you look here you can see some quite high power parts, starting with this big capacitor and this huge resistor down there. And I followed the circuit a little bit because I was not having a manual supplied with it, and also was too lazy to look it up on the website, to be honest. And it's quite self-explaining because if you're a little bit experienced with electronics, you can see that there is a bridge rectifier, and this is a simple power supply. So you can power this directly on the 230 volt mains. And if I have a look here, you can see there is L, which means phase. There are two switching contacts for the light bulb, and N, which means neutral. So there you can connect your mains and it will work. Okay, I think you may think the thing is an LED, but it isn't. I think it has something to do with the sensor. I haven't yet found the oscillator. Either it's this transistor here with this circuitry, or it's this LED thingy, because this thing is transmitting, if you want to call it like that, on around 27 gigahertz. So let's have a physical look on the circuit board. The circuit board is very tight, so you can throw it around and it will hold. But what they could have done is they could have added some glue between the relay. As you can see here, there is a gap. Just add a small drop of glue and it would be perfect. Of course you would get in trouble if you ever wanted to desolder the circuit board and put it in service, but since there are only surface mount components up there, you are anyway only soldering on top of the board. Here they could have added a screw, a hole for a screw, as they could have here added a hole for a screw, so you can mount it in a housing. They forgot that, but well, they wanted me to review this, so I'm honest about it. A good thing is that below this capacitor there seems to be some kind of fuse, so if there's something going wrong in the circuit, it won't burn down the house, it will just pop the fuse and won't work anymore, but it's safe. Okay, in the next clip I'm going to test it. Now I'm going to test the radar module, and you can see the small light bulb here. This is a 230 to 260 volts or something like that. It says 5 to 7 watts. It's a small light bulb. I don't know exactly the value, but it's very low power. I'm powering the module with an isolation transformer, so it's 230 volts connected to it, but because it gives me a little bit nervosity to connect such a module directly to 230 volts, I'm connecting it via an isolation transformer. I know that the picture isn't perfect, but you can see the module. You can see it over there, where my finger is, and there is obviously the light bulb. I have placed it in a position that I can go to my bed. I tested that before and it works. My bed is like a little bit more than 6 feet away, 6 to 8 feet or so away from the module, and I'm going into my bed and hold silent, and after the module turns off, I'll raise my hand, which means movement, and you will see that the module will turn on again. I mean, the relay will turn on, which causes the lamp to be turned on. Okay, I'll test that just right now, and now I'm going to connect the module to the 230 volts from my isolation transformer, and when you turn on the module on the mains, it will first switch on the relay. So I'll turn it on now, and you can see that it works. Now I'll go to my bed and wait. So now I'm in my bed, I'm laying here and having a nice time, and I'll wait until the module turns off, and then I'll raise my hand. So now the module is on. I cut the video there because it takes a while. So now the relay has turned off. What I'm now going to do is I'm now going to raise my hand and the module will turn on the lamp again because of the movement. So I raise my hand now, and you can see the lamp goes on again. So this is pretty much what these modules are used for. I go back so you can hear me better. So I'll turn it off again, because this is some kind of DIY isolation transformer which shouldn't be loaded that much. It's a low power transformer. But as you can see, it works. So if you hold still for a while, the module will turn off the light bulb again, and as soon as there is some movement, it will turn it on again. And of course, as long as you are moving, the module will keep the light bulb on. This is quite useful because you can place it, for example, in an entrance of a house, and then as long as you walk in the room, for example, you change your clothes or something, or to put your shoes away or something like that, it will keep the light on. But as soon as you leave the room, it will turn the light off after a while. The only flaw about these modules is that they are always consuming power, because obviously there is a transmitter and a receiver or something like that inside, which is always on and will consume power. Okay. So now I'm going to test the power, or better measure the power from this device. Therefore I've made a simple circuit. I've just added a 100 ohm resistor in series to the circuit, and now I'm connecting my meter to it, which can measure AC voltage. I'm in the 10 volts range. So this is a way that you can use for measuring current if you don't have a meter that can measure AC current. I do have one, but I was too lazy to put batteries in it, and so I just took this one. So do not do this on 230 volts. I'm doing this on my own risk, so no recommendation for rebuilding this. But I know what I'm doing because I've had an apprenticeship in this electrical stuff, and I do know what I'm doing. So I'm doing this on my own risk. Don't do this on yourself. Anyway, here is the module with the 230 volt leads connected to the isolation transformer, and in series with the module there is the resistor connected. So now I'm going to connect it to the transformer, and we will see what it's consuming. So I connect it, and there we go. You could hear the relay clicking, and it pulls around 30 to 40 milliamps from the 230 volt side, which is kind of high. I mean, it's not something that you would really notice on your bill, but it's kind of high, and that's because of the cheap power supply they've built in. They're just using the capacitor to, with the frequency, drop the voltage a little bit, and lots of voltage is being heated in the big resistor. So I'll wait until the relay switches off, and I'll hold still that it stays off, and we can see if the current consumption goes down. Now the relay has turned off, and as you can see, it does move a little bit lower. I'm holding very still so the relay stays off. It does move a little bit lower, but yeah, as you can see, it's still consuming a little bit of current. Okay, that was the current consumption show of this module.